So first and foremost, can you tell any one property of a matter? Any property of a matter? Any general property?
Matter is anything that acquires a space.
Okay, yeah, exactly. Any other properties? Actually, matter has different properties. Also, they comes in different states.
Yes, sir. Solid, liquid, and gas.
Yeah, actually. So also there is one more property of a matter which we will be studying, that is called what? Yeah, elasticity.
Yes, sir.
So what is
Yes, sir.
elasticity?
Ability to bend,
Ability to bend. Okay. Apart from that,
change shape,
change shape. Okay. Bend, change shape. Any others? Now, how does they bend? Or how does any object bend?
Uh,
Hmm?
until and unless we apply some force,
Okay, exactly. When we apply force, then what?
it's straight or like
Its shape may change, may or may not,
yes,
actually.
yes,
Now,
sir.
depending on what? How much force you are applying.
yes,
Now, first thing is if you try to pull a rod, a steel rod, what
Yes, sir.
what will happen? It will not change the shape. But if you try to stretch some rubber, then what? It will start stretching. Now, why to studies elasticity? Now, second question is, first thing is it's clear that it is some property of a matter. Then, why to study elasticity? Why it is important? Generally in physics, what do you study? In physics, you study how something behaves, how it evolves. Because once we know that, or once we have control over that, what we can use that. Now, let's say you have a huge earthquake. Let's say it came and hit. Now, depending on your properties of a material, what it can either bend or it can collapse. So that's why it's very important. Now, elasticity is slightly different. It's bent, change shape. It's partly correct, but what the actual definition of elasticity is when you apply certain amount of force. Clear? Then what
yes,
will
sir.
happen?
Yes, sir.
Some energy might store,
Yes,
some energy might get stored, and later on,
yes. Now let's say when you apply the force, what? This body will try to resist.
yes, sir.
If you apply a force in this direction, this resistive or restoring force will be applied in this direction because it will always try to oppose it.
Yes, sir.
And elasticity is basically that property. The property by which a deformed body try to come back to its original shape. That is basically elasticity. If you stretch something, if it comes back to its original position, that is basically elasticity. That medium you can call as elastic. Why? Because it stretches and again comes back to its original position. Now, if you stretch a plastic, what will happen?
It won't be stretched, sir.
Have you ever tried stretching a
Yes, sir. It will be
wrapper, a sweet wrapper or something?
original form.
It will stretch, but it will not come back to its original state, sir.
That means it is not a elastic.
Elastic.
That body is not an elastic. That is basically a plastic. Now, how do you define elasticity? Second thing is, before that, first you have to learn about stress. What is stress? Because that is this is a very familiar term which we all use. I'm having a huge stress or something. There is another general term for that also. Instead of using I'm under high stress, what do people usually use?
Tension.
I'm under huge pressure or something.
Huge burden.
Burden.
Pressure.
Okay. Basically, what? Yes, stress is pressure. It's kind of. Now, first, one thing is clear. When you try to stretch anything, what? There is a restoring force which will try to bring it back to its original position. That is basically a restoring force. Because it always tries to restore the system to its original form. So that's why it's called what? Restoring force.
Force.
Clear? Now, basically, the stress is as a dimension
Pressure.
pressure. It is what? Stress is restoring force per unit area. Force per unit area is basically a pressure.
Yes, sir.
Clear? So what will the dimension of stress? The dimension of stress will be Newton per meter square, because unit of area is meter square. This is in SI unit. SI unit. And force, what is the unit of force? Unit of force is Newton, and unit of area is meter square. That is basically a stress. Clear?
Yes, sir.
Now here is, let's say if a body has a very less stress, then what will happen?
Sorry, it won't come back to its original state.
It will not come back to its original state.
Right.
Have you learned about Hooke's law or heard anything about Hooke's law?
No, sir.
Okay.
Yeah.
Before-
Heard, but sir, forgot.
Okay, no problem. Let's talk about strain. What is strain? Now let's talk about strain. Okay. Now when you stress this body, what happened? Let's consider a one-dimensional object so it will be easier for you all to visualize. Originally, it was of this size. Let's mark this with this one. Now you applied certain amount of force over here. Then what will happen? It will stretch out.
Yes, sir.
Can you see there is a change in dimension or change in length of this body?
Yes, sir.
Initially it was of this length. Now it has changed and there is an additional length. Can I say delta L or something? Small change.
Sir.
So,
Let's say for a timing it was 5 centimeter. Now it has went to what? 6 centimeter.
6 centimeter.
6 centimeter. Now what is the change in its length?
1
1
centimeter.
Centimeter. Basically a strain is
1 centimeter.
ratio of
Length. Change.
is ratio of delta L by L. Strain is. What does that mean? It's a ratio of change in dimension to its original dimension. Clear?
Yes, sir.
Yes, sir.
For the strain will be how much? 1 by 5.
1. Yes, sir.
So,
Now, if there is no change, let's say you are trying to pull a steel rod, then there won't be any changes. Now it depends how much force you are applying. Let's say you are extremely strong, then you will be able to stretch it. But let's consider that you are not being able to stretch it. Then its change in dimension will be how much? 0. Then the strain will be how much?
0.
0. There won't be any change. Yes?
it also depends upon the material, right? It also depends upon the material, right?
It depends on the material. It depends on the, actually it just depends on your change in length.
Oh, yes, sir.
Oh, yes, sir.
Because it depends. Let's say you have a particular material. Let's say it depends on the nature of a material. Okay. But at that time, what you should have a constant force applying on it. Because if the forces keep on changing, if you try to stretch a rubber band with certain amount of force, it will stretch. Let's say you try to stretch a rubber band with force F1, then it's stretched by 1 centimeter. Yeah.
Yes, sir.
You have a steel rod. Again, you apply another force. Again, it changes by 1 centimeter. In both, you can say the strain is same. 1 by, let's say this is 3. This is also 3. 1 by 3 over here also. It is 1 by 3. Clear? So it just depends on your change in your length or shape.
Yes, sir.
Clear?
Yes, sir.
Yes, sir.
Now there is Hooke's law. What does your Hooke's law tell you? Hooke's law tells you that the optimum, what does it tell you? The optimum method of catching a fish is with this kind of hook. That is what the Hooke's law says. Actually, the what your Hooke's law says is for a given material, okay? For a given material, what? Stress by strain is constant. That is basically your Hooke's law. Now, this quantity which is constant, now it depends on your nature of a material. Clear?
Yes, sir.
Yes, sir.
That is basically the form of Hooke's law which you have shown is this one. Have you seen this? Force is proportional to the position. Force is equals to negative kx. For oscillator or any body, this was your Hooke's law previously. What does your Hooke's law tells you is, if you try to stretch a body, if it stretches by, let's say, by 1 centimeter, then this change is directly proportional. The amount of force which you apply is proportional to change in position. Clear?
Yes, sir.
That is how I think you must have looked. For a timing, leave it. We will come to it later. So let's talk about here. For Hooke's law, what your stress by strain should be constant. Have you seen this kind of equation?
Yes, sir.
What is this equation
Yes,
of?
sir.
Equation of straight line.
Straight line.
Straight line. If we draw this, what you'll get? For a timing, what was your C? C equal your y intercept. For a timing, let's put y is equal C equal to 0. So it's y is equals to mx. So if you plot this, what you will get? Y versus x. What you will get? You'll get a straight line.
A slope.
Yeah.
Yes, sir.
If we plot this to quantity, what you'll get? You'll get a straight line. And the slope will be given by what? Here, m. Do you all remember this?
Yes, sir.
Yes, sir.
Yes, sir.
Now, why I am telling you about this is, for Hooke's law, can you say that stress by strain is constant? I can write this above equation, y by x is equals to m, where m is what? Constant. Because that is a slope, that is constant. So can you see both of the relation are quite same?
Yes, sir.
If you put
Yes, sir.
y and strain as x, what? You'll get what? Constant. So what will be the two different axes that you should plot with? For y, we will be using stress. For x, looking from here. This, you put this. This, you put this. For a constant, let's use this as E, okay? For timing, let's use as E. E or K?
Sir.
What do you prefer?
K, sir.
K, okay, let's go with K. This you have to replace by this.
Y by X equals to K.
Again, it will be what? A straight line. Where over here you will have stress,
Stress,
over here you
strain.
have strain. And the slope will give you what? That constant.
Yes, sir.
Now, how to find the slope? It's very easy. Ratio of this two will give you a or with the angle also you can get. And this is a reason where this is a reason, R-E-Z-I-O-N. This is a reason where your Hooke's law follows. Is it clear?
Sir.
Yes, sir.
For any material to follow the Hooke's law, stress versus strain diagram should be what? A straight line.
Yes, sir.
Yes,
Clear?
sir.
Can you tell me the dimension of this constant? Looking into this out of equation, can you tell me the dimension of this constant? What is the dimension of stress? Sorry, what is the unit of, let's say, can you tell me the unit of this constant? What is the unit of stress? This was basically a pressure.
Pascal.
Newton per Pascal, yeah, meter square. What is the dimension of strain? Strain does not have a dimension. Because what?
Meter cancels.
Because you are dividing length with length. So it won't have a dimension. So strain is basically a dimensionless quantity. So what will be the dimension of your constant? It will be basically a pressure. Clear?
Yes, sir.
Is it clear till here? Any problem?
No, sir.
To summarize, if you apply certain amount of force on a body, what? There could be two things. There are two possibilities. One possibility is what? No change. And there will be a change. Now, depending on your change, what do we define? There will be a restoring force. When we apply a force in this direction, there will be a restoring force. And depending on this change, we will define strain. This is change in dimension by its original dimension. Clear? And we talked about Hooke's law. Which said that stress by strain should be
Constant.
Now let's discuss about your stress by strain diagram. Stress by strain diagram. One thing is obvious. Initially, how the shape will look. Over this side you have stress, this side you have strain. Initially, for some time, is the diagram visible?
Yes, sir.
Yes, sir.
Now, this is a reason where your Hooke's law follows. That we have already seen. It will be a straight line. But after that, something funny starts to happen. It will start behaving in this manner. Let's draw it with different color. That's it. Now, what does this tell you? This is a region, this is a linear region or a straight line where your Hooke's law holds. Let's start labeling it. 0, this is A. This point with maximum, this is B. This is D. This is C. This is F. And this is E. Initially, first thing is very clear. If you apply a force, what there will be a restoring force which will give you stress. That is trying to pull it back. You are trying to pull it on this side. The body is trying to pull it back. There is a restoring force, and it always and it linearly depends on what, how much displacement or how much you have stressed it, or how much force you have applied. So it will be a straight line till here. This is the reason where your Hooke's law follows. Hooke's law follows. After that, it will start behaving funnily. Can you see there is a certain small hump over here?
Yes, sir.
After a certain time, what? There will be a huge deformation because the strain is extremely high, but the stress will be extremely low. Have you tried stretching this? Have you tried stretching this wrapper or this sweet wrappers or something?
Yes, sir.
Initially, if you apply a small amount of force, very lightly, what it will try to come back to its original position. Clear?
Yes, sir.
Yes, sir.
That is basically where your Hooke's law follows. As soon as if this follows, if your Hooke's law follows, then the body will always come back to its original position till here. Then after that, deformation, permanent deformation starts to appear. Because as soon as you start stretching with certain high amount of force, in a sense you are increasing a force, what will happen? The wrapper will permanently get deformed. As soon as that region is reached, then have you all noticed the sweet wrapper will all of a sudden it will stretch drastically after a certain point.
Yes, sir.
Have you all noticed it or not?
Yes, sir.
Basically, that is your this region. There is a huge deformation because there is a huge strain. There's a huge change in length, but there is no or very little change in your stress because the body is not trying to pull it back. So that's why it's stressed extremely large. So after that region, what will happen? Again, it will start become tight. Again, it will try to resist. So the stress will slowly increase till this point. Then after that, what? The stress will start slowing down. Then what? The object will break. The object will break over here. Is this point clear?
Yes, sir.
This is here elastic region. Till here. Till here, this is here elastic region. Up to here is your plastic region. And basically at A, what? It breaks down. Do you have any questions? Any questions still here?
No, sir.
And there are few technical terms. What are these different points called? That we can write. Now, O to B region is basically an elastic region where again it will come back to its original position. This is a plastic region where it will get deformed permanently. Now there is the point B where there is a large increase in strain. This point is basically called what? A yield point. Yield point. Clear? Now the yes, this breaking stress is called what here? Ultimate strength. Because the wire breaks over here. Clear?
Yes, sir.
Do you have any questions still here?
No, sir.
So it's completely clear. So I think we will do till here. I will discuss what we are going to do in your next lecture. This is just a small summary, okay, for your next lecture.
Yes, sir.
Now, previously, what did we say? If you apply certain amount of force, what there will be no change or there could be a change. For all our lecture, we will just talk about how the body changes. Because if the body does not change, what? Then it's a very boring kind of thing. So if there is a deformation or if their body changes, then you can apply force in three different kind of system. In one-dimensional object. What is a one-dimensional object? Let's consider wire as a one-dimensional object, okay? Which is just like a straight line.
Line.
If you apply force, what will change?
Length.
Exactly, length. This is for your one-dimensional. Can you tell me a two-dimensional object?
A paper sheet.
Okay, exactly, a paper sheet. If you apply force, what will change?
Size and length.
Yes, exactly, size. Size or is area. Can we say size or area?
Yes, sir.
So
And for a three-dimensional object?
Box.
Hmm?
Rubik cube.
Okay, Rubik
Box.
cube, exactly. Rubik cube, anything. If you apply force, what will change? Its volume will change. Because if you apply a force from here, it will start splitting on both the sides, no? So that's why its volume is there.
Oh, yes, sir.
So there are three kind of object because that is basically what we see. A wire, a paper sheet, and a what? Your cube, let's say. For if you apply force, its length will change. If you apply a force in your two-dimensional object, what will change? Area. And
Area.
if three-dimensional object, what? It has a volume.
Volume.
So that's why its volume will change. So depending on this, you have different constant that we'll talk about later. So if you have any questions, now you can ask. Any questions?
No, sir. No, sir.
Okay, then